Hi everyone, I hope you're okay, and I really hope that guys the videos will keep uploading and helping you out. In this video guys, I'm just going to tackle question 12 and 13, and this is the last video, by the way. Please note that the other 6 videos are already uploaded, and you can just click the link on the description below, download the question paper on your own, answer the questions with me. If there are things you're not sure about, please do write on the comment section. I will come back and assist you. Okay, question 12. Question 12, ne? We are given triangle ABC, and we are told that E and G are on line AB, and then D is on line AC. And we are also told that AG and GB are equal. ED is parallel to GC, and then we are also told that DF is parallel to AB. The first question, you're supposed to prove that CF over FG is equal to GE over EA. This was going to be easy, guys, if we had a line joining E and F, and that line, if it was parallel to this, it was going to be easy because we're just simply going to say we were just going to use the proportionality theorem altogether. But since that's not the case, that means there are things we have to do to prove this statement. Okay, the triangle of focus in here, guys, is this one. We need to focus on this triangle. Okay, that's our triangle of focus, ne? With ED parallel to CG, right? We can therefore conclude that GE over EA is equal to CD all over DA. This is true because of proportionality theorem, prop theorem. Right, together, and we can be able to see the prop theorem. Why? Because ED is parallel to CG. Okay, and then now if we focus on this line, which is parallel to this one, we can therefore conclude that CF over FG is equal to GE. No man, excuse me guys. CF over FD is equal to CD all over DA. Alright, together. If these two lines are parallel, that means this over this is equal to that over that. Ne? Okay, we can therefore conclude that this is equal to this. Why am I saying this? Because both of the two ratios are equal to the same thing, which is CD over DA. We can therefore conclude that GE over EA is equal to CF over FG. This thing is true because both of these ratios are equal to the same thing, and that same thing is CD over DA. I didn't write the reason here, ne? It's important, guys, for you to write the reason. Let me write it now. The reason was prop theorem, ne? And we could see prop theorem because DF is parallel to AB, or you can say AG. It's up to you. Okay, now since we've proven this statement, let's move to the other part, ne? We are given CF over FG. We are supposed to find GE over GA. Okay, remember that we've just proven that GE is equal to GE over EA rather is equal to CF over FG. We've just proven that statement in the first question. Are you together? But we are told that CF over FG is equal to something. So I can just substitute CF over FG with that thing. that means this is 2 over 1. So this simply means that, guys, it simply means that that in this triangle, since this is 2:1, that's 2k, and we have k here. That means the entire length of AG is just equal to 3k. So for me to find the length, the ratio of GE to GA, this is the same as saying 2k all over 3k, and then I'll simply get 2 over 3, which can be written like this. Okay, then now I'm supposed to determine the numerical value of df over AB. df over AB. Okay, what do we know about df and AB? I know that df is equal to GE. Why am I saying that? Because this shape over here is a parallelogram. Why do I have the nerve of concluding that's a parallelogram? Let me erase here. I can simply say that I can simply say that this over here is a parallelogram. Why? Opposite sides are parallel, and since they are parallel, it simply means that the opposite sides are parallel and equal. So if the opposite sides are parallel and equal, that simply means df is equal to GE. Are we together? Okay, and remember that you are supposed to find the ratio of df all over GE. Are we together? I know that df is equal to, no man, it's df over AB. Okay, now I do know what I can link df to, because I can link it to GE. I've calculated GE previously. Are we together? And remember that I said this is just 2k, and that will be k. Are we together? And the entire length will be 3k. But there was this statement that I was told, that AG is equal to GB. So if that's 3k, that means GB is also 3k. Are you together? So the entire length over there will be equal to 6k. Are you together? So I can therefore say that the ratio of df all over AB, okay, let me write that at the bottom. The ratio of df all over AB is equal to the ratio of GE all over 2 times AG. Are you together? I'm saying 2 times AG. Why? Because AG is just this length alone, which is 3k, and AB is 2 times 3k. Are you together? So GE, remember that GE was just 2k. This will be 2 times 3k. So the final answer is just 1 over 3. So the ratio of df to AB is equal to 1 is to 3. That's how, guys, we would have answered the proportionality question. Now let's move to question 13. Question 13, guys, we are told that in the diagram, the circumscribed circle for triangle BCF is given. And then we are told that AB and AC are tangents to the circle and to the circle, rather, at B and C respectively. FE and FG, FD are perpendiculars from F. Okay, they're perpendiculars from F to AB, BC, and also to AC. Nah? The first question you're supposed to do is to prove that the triangle FEB where is FEB? This is FEB, is similar to triangle FGC. Okay, how can I do that? I'm comparing two triangles, right guys? In triangle FEB and triangle FGC. Okay, what remember that guys, for me to show that triangles are similar, I just need to show that the two triangles are equiangular, and if they're equiangular, therefore they are similar. Are we together? Okay, angle B1 is equal to angle C2. Angle B1 is equal to angle C2. This is a turn chord theorem. Are you together? Where is it? Angle B1 is equal to angle C2. Turn chord theorem. Okay, and then we also know that angle E2 is equal to angle G1. This was given to us. Angle E2 is equal to angle G1. Both angles are just equal to 90 degrees. Are you together? So we can therefore conclude that angle EFB, we can therefore conclude that angle EFB is just equal to angle what? FCG or GCF. FCF. Angle CFG. This is just the third angle of a triangle. Third angle of a triangle, yeah? And therefore you can conclude here that a triangle FEB is similar to triangle FGC. This is true because the two triangles are equiangular. Are you together? But guys, please note, the theorem does not end there. It simply says that when two triangles are equiangular, then the two triangles are similar, and hence the corresponding sides are in the same proportion. What are corresponding sides? Corresponding sides are sides which subtend equal angles. So if I have angle B1, if I just focus only on triangle FEB, angle B1 is subtended by line FE, and then angle E2 is subtended by line FB, and then angle EFB is subtended by line BE. Are you together? And then if you focus on the other triangle FGC, angle C2, my handwriting is horrible, I can't even see it. Angle C2 is equal to is subtended by line FG rather, and then angle G1 is subtended by line FC, and then angle CFG is subtended by line GC. Are you together? So since guys the two triangles are similar, the corresponding sides are in the same proportion. What do they mean whenever they say the corresponding sides are in the same proportion? It simply means FE over FG will be equal to FB over FC, and that will also be equal to BE over GC. Are you together? You don't have to write these guys in this question. I'm just showing you how does the theorem work. If you stopped here, you are done. You would have gotten your full 3 marks. Is it 3 or 4? 4 marks. Okay. FE over FG. FE over FG is just equal to FB over FC, which is equal to BE over GC. All together. This these statements are true because a triangle FEB is similar to triangle FGC. Okay, and now we are supposed to prove that FG squared is equal to FE times FD. FG squared is equal to FE times FG. Né? If we can focus on this triangle BFG, and also triangle CDF. So I said triangle BFG and triangle CDF. Okay, we can see that guys, in this thing, né? Angle C1 is just equal to angle B2 because of tan chord theorem. Are we together? And D2 is equal to angle G2. The two angles are both equal to 90, and then we'll have a third angle of a triangle. So C1 is equal to B2. B2 is equal to C1. This is tan chord theorem. B2 is equal to C1, that's tan chord theorem. And then we have angle G2 being equal to angle D2. Both of these angles are equal to 90. Angle G2 is equal to angle D2. Both of the angles are just equal to 90. This was given to us. And then we'll have the third angle of a triangle. Our third angle of a triangle will have BFG being equal to CFD. Angle BFG is equal to angle CFD. This is just the third angle of the triangle. Therefore, triangle BFG is similar to triangle CFD. Why am I saying that? Because I've shown that the two triangles are equiangular. All together. But even here, guys, the theorem does not stop here. It does not end here. If the two triangles are similar, then the corresponding sides are in the same proportion. So B2, if we focus on triangle BFG, né? B2 is subtended by FG. B2 is subtended by FG. And then G2 is subtended by FB. And then BFG is subtended by line BG. Excuse me. And then if you go to the other triangle, angle C1 is subtended by FD. Angle D2 is subtended by FC. And then angle CFD is subtended by DC. Okay. When they say the corresponding sides are in the same proportion, they simply mean FG over DC is equal to FB over FC and BG over DC. Just like that, né? FG over FD is equal to FB over FC, which is equal to BC over DC, né? This statement is true because a triangle BFG is similar to triangle CDF. Are you together? For me to prove this, I can just take this part from the first question and also take this part from the second question. Né? From the first question, let me write it in red. From the first question, I'll say FE over FG. FE over FG. is equal to FB over FC. This is true because triangle FEB is similar to triangle FEC. Triangle FEB is similar to triangle FEC. FGC rather, not FEC. Oh, guys, my handwriting. I can't even say it myself. But don't judge me. Thou shalt not judge. Okay, and I'll also take FG over FD being equal to FB over FC. I think I made a mistake there. Let me go and confirm. Is it FC? Yeah, it was FC. It was FC. We can all see, ne? Don't say I'm forging my answer. Okay, why am I choosing these two sets of ratios? Why? What I want to prove have FG and FE, ne? So that means I'm going to choose a ratio that has FG and FE in one pairing of similar triangles, and then another pairing of similar triangles should have FG and FD. Are you together? And coincidentally, I found out these will be equal to that. Why? Because both of them are equal to the same ratio, which is FB over FC. So I can simply say, therefore, FE over FG is just equal to FG all over FD. Are you together? Why? Both of these two ratios are equal to FB over FC. I can therefore cross multiply in here, and then I'll have FE multiplied by FD is equal to FG times FG, which is just FG squared. So I've proven the statement that FG squared is equal to FE times FD. That's how, guys, we would have dealt with that's how you would have dealt with this question. And I really hope that, guys, it helped, and just stay tuned, guys, and wait for more. Thank you.